Hi guys, we're back. And we're going to finish up this question on torsion and power. Okay, so in the first section, in the last video that we did, we solved for the minimum diameter for the motor shaft. Okay, and that was the shaft extending directly out of the motor. And we found the minimum diameter, and we used the power equation, okay, because the torque was given to us in power. Now, the second part of the question is asking us for the minimum diameter for the power shaft. Okay, the power shaft is this shaft up here that is being powered by the big gear from the motor, okay? And in previous questions, or in the previous actual question that we did with regards to gears and torsion, if you remember, we transferred the gears, the torque through the gears, okay? We just took a ratio between the gears and we transferred the torque and we were done. In power questions, you have to be careful. You can't do that all the time. You're gonna have to transfer the RPM through the gears, okay? So you're gonna transfer the speed of this gear to that gear, okay? And then what you're gonna do is you're going to solve for the power in the power shaft using that N, okay? And if you remember before, what might confuse you is that when we transferred the torque from a bigger gear to a smaller gear, okay, that what happened is the torque was reduced because the smaller gear couldn't transmit as much torque as the bigger gear, okay? In this scenario, the smaller gear will actually be moving faster than the bigger gear, okay? So that's something to consider, and it'll also change our answer a little bit, okay? So let's start. Hopefully when we write it out, it'll make a little more sense. Okay, so we're going to use this relationship. Okay, we're going to use that ratio to transfer it's the same as the diameter ratio that we used in the previous question. And if you'll notice though, there's a little bit of a trick in this question, and we're not given the diameter of the gear. Now in this one, we're given the teeth, okay? We're given the number of teeth in the gear, and that's a possibility. You can either be given the diameter of the gear, or you can be given the teeth. And don't get confused, don't freak out. It's exactly the same thing. You just take the number of teeth and you use that as your ratio, okay? So, for example, this large gear has 96 teeth, the smaller one has 16. Those are the numbers we're gonna use when we transfer the gear, or when we transfer the torque between the gears, or the speed in this case. So let's use that. So, in terms of, instead of using D1 and D2, we're gonna use the number of teeth, okay? So, we wanna solve for the speed in the power shaft, right? So we're just gonna isolate for that. So, and D1 in this case, okay, is our larger gear. D2 is our smaller gear, okay? As we discussed, the smaller gear is going to be moving faster because it's smaller, it'll rotate more than the bigger gear, okay? Obviously. And, okay, and we're going to just multiply both sides by the speed of the motor. And what is the speed of the motor? Well, we already found, well, I mean, that's given to us in the question. We found that earlier, and that's 360 RPM. Okay, and if we work that out, we can solve for the speed of the power shaft. Just throw that in your calculator. It's going to be 6 times 360, and that is going to give us 2,160 revolutions per minute. And that value is the value that we're going to use to solve for the torque in our power shaft, okay? And you know what, honestly, it's the same process that we did in the first part. We're just going to plug values in, and we're going to solve for T in our power equation, and then we're going to use the maximum allowable tau, and we're going to solve for D. So I'm going to go through that pretty quickly, just because we already did that in the question before. And you know, if you want to pause here and you want to just try the question and see if you get it right, go for it. Otherwise, I'm just going to start solving. So let's begin. Okay, we're going to use the power equation, right? Now the power is the same, right? It's 100 from the motor, okay? Remember, we're not transferring the power, we're transferring the speed of the gears when we're working with power. All right, so we have horsepower. Okay, we're going to multiply by our conversion factor to get it into the pound-feet per second that we want. Okay, and we're going to equal that to 2 pi, and we're going to use our power for the shaft, which is 2160. Okay, T is unknown. We're going to divide that all by 60. Sorry for the small writing there. And if I'll draw an arrow, we're going to come down here and we're going to solve just for T in this equation here. Okay, guys? We're going to solve for T, isolate for it, solve for it, and we are going to get okay, 243.15 pound-feet. Like we did before, let's convert that to pound-inches because we're going to be working with inches. So we're just going to multiply that by 12. Okay, we have our T. Now, what do we do next? Simple, same thing. We want to solve for the minimum permissible diameter, right? And we're given the maximum shearing stress in the shaft, same as the last part, it was 12 KSI. So let's continue with that. Okay, let's convert pounds to kips. Right, for C we're subbing in d over 2, which is equal to the radius, obviously. Same thing for J, we're going to use our J in terms of diameter, not radius. And once again, let's just solve for this equation, solve for D. So, I mean, like I said before, you can just stop the video and wait until the answer comes up. But I'm just going to put it down for you here. Solving for D, we'll give that D sub 2 is 1.074 inches, okay? And let me just do that in red for you there, and that's pretty much it, guys. That's a very common question. Yeah, it's a very common question that they ask you for the minimum permissible diameter. So, summing it up, you know, you solve for T using your power formula, and then you're going to sub that into your tau formula for your shear stress, and you're going to find the diameter when writing C and J in terms of D, and you're done. That's it.